let's talk about some inequalities. So remember, if you have a less than or greater than symbol, then whenever you write your interval notation, which is going to be your final answer, when you write your interval notation, then you are going to use parentheses. And if you have a less than or equal to or greater than or equal to symbol, then you're going to use the brackets. So it's the same interval notation when you do inequalities, whatever type it is. It doesn't really matter. And this one just happens to be absolute value. So remember, just like we did our absolute value equations, you're going to have to split this up to the positive and the negative. Now something else when it comes to inequalities, remember that anytime you have a negative, or you multiply or divide by a negative, that's when you have to flip that sign. So with our absolute value, if I break this up, I get a 2x plus 1 is less than 7, but whenever you come over here to the negative sign, you need to flip for the negative, because technically what you're looking at here is when is this 2x plus 1 going to be negative, because remember the inside is where you have the positive and the negative. So the guts of your absolute value is the positive and negative. So flip for the negative. That's the key here. That says flip for the negative. So then all you have to do is solve each one. So subtract 1 from both sides, and you have 2x is now less than 6. Divide both sides by 2, and x is less than 3. Subtract 1 from both sides here, and you have 2x is greater than a negative 8. Divide both sides by 2, and x is greater than negative 4. That's when you plug it on a number line. Now, whenever I make my number lines, I just put those values in there. In my math lab, it's going to have all of the numbers, and it's going to be multiple choice. But on your tests, you're going to have to put them in there again, so pay attention to that. Now, you are going to have each piece that you are graphing. So, if x is less than negative 3, then I'm going in this direction. If x is greater than negative 4, then I'm going to go to the right. So between these two are where I'm shading. Given the symbol, am I going to be using parentheses or brackets? Parentheses, that's right. So for our first one, so I'm actually going to have a parenthesis at negative 4 and a parenthesis at 3. So my final answer is negative 4, comma 3. Remember, this is an inequality, so there's more than one answer. It's everything between those two. Cool, let's do another one. So for this problem, we're going to do the same thing where we split it up, and I end up with 4x minus 6 is greater than 10. And don't forget to flip for that negative sign, so we have 4x minus 6 is less than negative 10. Now solve each one. If you add 6 to both sides, you now have 4x is greater than 16. Divide both sides by 4, and x is greater than 4. Over here on the right one, you add 6 to both sides. You now have 4x is less than negative 4. Divide both sides by 4, and x is now less than a negative 1. Put that back on a number line. And I now have from negative 1 up to positive 4. Now then we graph this again. So I want to look at where x is greater than positive 4, so I'm shading to the right, and where x is less than negative 1, so I'm shading to the left. So look, in this particular problem, they go to the outsides. Notice, on the previous problem we had, you were shading on the inside, and on this problem, you're shading to the outsides. It will always be one or the other. You will either shade between your two numbers or to the outside of those two numbers. If you are shading in the same direction, you did something wrong, and typically that's because you forgot to flip for the negative. So keep that in mind. Also for this problem, notice we're going to have parentheses because it's just that greater than symbol. So I'm going to write it. Don't forget, anytime you have the gap in the middle, you have to use your union. So it's a direct translation, negative infinity up to -1, parenthesis, union for the jump, parenthesis, 4 to infinity. Now look at this union symbol. This does not have a tail on the U. It just goes like a U without a tail, basically. That makes a difference. The actual U with the tail on it means something different. So make sure whenever you write your final answer and you're using that union because you're shading to the outsides, it's an actual union symbol. Okay, great job. Let's try another one. All right, here we have a problem where we can solve for the absolute value first. So you have to isolate your absolute value first and then you solve for it. So leaving the absolute value symbols on there, I'm going to add 1 to both sides. Now I have the absolute value of 2 minus 7x is greater than or equal to 5. Now at this point, we can break it into the positive and negative. So I have a 2 minus 7x is greater than or equal to 5, and 2 minus 7x is less than or equal to a negative 5. So now we solve each one, just like we have been doing. So I'm going to subtract 2 from both sides. Negative 7x is greater than or equal to 3. Now look what happens. For this problem, whenever I'm going to clean this up a little bit, a dividing by a negative. Anytime you divide by a negative, what do you have to do with that inequality symbol? Flip it. Exactly. So then that's going to leave me with a negative 3/7 over here on the left. Do the same thing. On the right, I'm going to subtract 2 from both sides. Negative 7x is less than or equal to a negative 7. If I divide both sides by that negative 7, we flip the sign, and that's what gives us a 1. So put that on the number line. Again, this is why whenever I write the number line, especially when you have fractions or something different, it's easier to write it out just the numbers rather than all of the different values that are between there. So I have x is less than or equal to that negative 3/7, and I have x is greater than or equal to that 1. Now this is the first time that we've had this or equal to symbol, so we get to use brackets. And then we just write it out. So we go from negative infinity to negative 3/7 bracket union with 1 to infinity. Now even though my symbol is bracket, anytime you have infinity, you're always still just going to use parenthesis because you can't land on infinity, just up to but not including. Cool. Great job. Now let's take a look at these 3 problems. Look at this first one. Let's go back and think about what the definition of absolute value is. The distance from 0. So if I'm looking at this first problem and I want the distance from 0, the distance, and in this instance, when my absolute value is greater than negative 4. So greater than or equal to, greater than, it's equivalent, because I'm looking at the values that are greater than negative 4. Absolute value is always positive. So what we're actually looking at here is whatever this is, when I take the absolute value of it, that's going to be some positive number that's going to be greater than a negative number. Are positive numbers greater than negative numbers? Every time, right? So when you have absolute value and you see that negative sign, wee, 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 lights are going off, something's flashing, you notice that if it's with a negative number, the positive, is always greater than that negative. So our answer for this one is all real numbers. And you can write all real numbers in interval notation as negative infinity to positive infinity. Cool. Let's do this next one. Here I have a positive number That is less than a negative number. Will a positive number ever be less than a negative number? No, it won't. Good. So if that's the case, then this is no solution. Sometimes it's written like a 0 with a line through it. That stands for the empty set. Those are equivalent statements. Nice. And then last but not least, look at this problem down below. If I have a 5x plus 15 is equal to 0. If I want to know what value of x is going to make this the distance from 0, and I am already on 0, then there's only one solution. So I'm looking at 5x plus 15 equals 0 because I'm already there. Subtract 15 from both sides, divide by 5, and in this instance you only have one solution because you're already at 3. Cool. Great job with your absolute values.